In this video, we want to solve this equation here using the change of base formula and then solve it again without the use of the change of base formula. So we can use any other base, and I'm going to go with the natural log, ln. So say this is going to be ln. The way it works then, you pick the base, we pick base c here, so natural log, whatever this is, and it's over the same log, same base of whatever the initial base is. We get that. Same thing with the next. We're going to go from log of base 4 to, again, natural log. So this will just be ln of the variable x, and it's ln of whatever that given base is. In this case, it's 4. And then it's plus ln of the variable x in this case over ln of the base 2 in this case equals to 7. And then we can simplify this using the some properties of logs. So remember 16 is the same thing as 2 to the 4th. So I'm going to rewrite this as 4. This is 2 to the 4th. The 4 comes out, and then this is replaced by ln of 2. And that'll replace this part right here. Same thing, ln of 4 is the same thing as ln of 2 squared. Properties of logs allows me to bring that exponent out in front as a coefficient. So instead of ln of 4, I can write that as 2 ln of 2. That replaces this part. So now we have this in the denominator. And for this one, it stays the way it is. And then I'm just going to clear the fraction, so I'm going to multiply through by the common denominator here, which is going to be 4 ln of 2. So for the first one, it has denominator 4 ln of 2, so that's going to cancel. And all I'm going to have here is ln of x. And that's going to be plus. For the next one, it has a 2 ln of 2, so the ln of 2, the ln of 2 is going to cancel, and then 2 into 4 will go 2. So this will give me 2 ln of x plus. For the next one, ln of 2 cancel, leaves me with a 4. So this would be 4 ln of x. And on the right side, I'm left with this product right here. So 7 times 4 is 28. So it's going to be 28 ln of 2. And then we can just add these up on the left side. All we got is ln of x, so it's 4 and 2 and 1, so this will be 7 ln of x. That's going to equal to 28 ln of 2. I go up here now. So far then we have 7 ln of x is equal to 28 ln of 2. We can divide by 7 here to simplify. Divide by 7 here. This cancels out. So I'm going to get ln of x equal to 28 divided by 7 is going to be 4. It's 4 ln of 2. And so now this 4, again, properties of logs, I have a coefficient here. I can bring this up here, make it into a exponent. So I can write this as ln of 2 to the 4th. That's 16. ln of 2 to the 4th, and 2 to the 4th is 16. And then using properties of logs, I have the ln of x, the base here, remember, is understood to be e. So I can write this go from log, natural log, to exponential form. So this would tell me that x is equal to base e, because this is c, taken to this power right here, ln of 16. So this would be ln of 16. But anytime you have any kind of setup like this, where you have the base e, and then the exponent is the natural log ln of some number, remember the base here is e. So this is e and this is c. The answer is always going to be whatever's here, the argument of the natural log. So this would tell me that x is equal to 16. That's the solution using the change of base formula. To use another method here, okay, it wants us to use the change of base and then another method not involving the change of base. That is this formula. And this is the formula that I'm going to use. Anytime you have the log of some expression or variable to some base, notice that's equal to the log of the variable x to what, pick a power. We're going to deal with positive powers here. And then, so let me show you again an example. We have the log of 8 to base 2. That's equal to, again by definition, the logarithm is the exponent. You have to take this base 2 to get this expression, this value here, 8. So 2 to what power will give me 8? And 3, right? 2 to the third is 2 times 2 times 2, that's 8. But notice if I go ahead and take this base to a power, positive power in this case, and I take the argument here to the same power, it doesn't change it. So let's pick 2. So let's square that base. It becomes a 4. And let's square the 8. It becomes 8 times 8 is 64. Does that still equal to the same value of 3? Well, does 64 by definition has to equal to 4 taken to whatever we put here, so we're assuming it's going to be a 3 here. So is 64 the same thing as 4 to the third? Yes, 4 times 4, 16 times 4, 64. So this does work. So you can always do that with any base, any value, cube it, as long as you cube the argument, or square it, or take it to the 4th power, and the 4th power, and so on. So here's what we're going to do for this one then. I'm going to leave this one at 16. The space is 16, so this will stay log of x to base 16. I want them all the same. Okay, if I square the 4, that's going to give me 16. That's okay. It doesn't change it, that as long as I square the argument also. So this will be log of 4 squared is 16, so this base is 16. Square the x. No problem there. It'll be x squared plus, and this will be the log. Okay, to get that base 2 to 16, I'd have to take it to the 4th power. So 2 to the 4th is 16. This would become 16. I can do that as long as I take the argument to that power. So this would be x to the 4th. That's equal to 7. So now I have the same base. 16, 16, and 16. I have a sum here. So remember, whenever you have a sum, you can express that as a product. So let's look at the first two here. It's a sum. Base is the same, so this works. This becomes a 16. Then I multiply these out. What is the product here? The sum goes to product, so this would be x times x squared. It would be x to the third. So this would be then x to the third, but now I still have a sum. X to the third here. Well, let me just go ahead and write it. So the first two can be combined this way. Bring down the log to base 16 and then multiply. And then I have a plus log of x to the fourth to base 16 equal to 7. And now again, because I have a sum, I can do the same things. So I'll put it over here. This will be the log base 16. Okay, then you multiply these two. X to the fourth times x to the third is x to the seventh. So I get log x to the seventh to base 16 equals to 7. So now I have the logarithmic form. Let's just go to exponential. By definition, this expression here, x to the seventh, has to equal to this base 16, take it to that power 7. This will be, have x to the seventh is equal to 16 to the seventh. So here we take the 7th root here and the 7th root on this side. So it's the 7th root of x to the 7. Of course, it's going to give me x. The 7th root of 16 to the 7th. Just multiply the power here. 1 7 times 7 is 1. This comes out to 16. You can see this one comes out a little bit easier. Let's step through this one. X equal to 16, which is the same thing we got using the change of base. The only problem though with this method is it's not always going to work. The change of base formula, if you have expressions, an equation with different bases, that's always going to work. Here you have to be careful with powers. If you can match it up this way, it's going to go fairly easy. Thanks for watching. We'll see you next time.